Hello and welcome to Physics Doctor. My name is Dr. Kanshyam Tejani and let's start class 11, chapter number 3, motion in a straight line. And the similar content is covered in JEE NEET unit number 2, Kinematics. And this is session number 7 of chapter number 3. And in this session, we will learn relative velocity in one dimension along a single axis only, either x axis or y axis. And how? By solving large number of examples from the NEET, JEE and JEE Advanced. So let's go. So let's start with this. What is meaning of a relative velocity? See, in the physics, when we talk about physical quantities, a relative term is used many times. Say for example, let's have a girl, a cute baby girl we can see here. Let's call it Chinky. And a sweet boy we can see here, we can call as a Chinks. Different name, unique name. Now see that Chinky, suppose, is having 3 feet height and this Chinks is having height approximate 2 and 1/2 feet. Can we say a relative height with respect to Chinky to Ching is this difference is 1.5 feet. In day-to-day life also we usually compare heights among the person. Yes or no? You say that my height is 2 feet, or you can say 1 inch or 2 inch is higher than some other person. And we like to have greater the height in the reality. So see here the term a relative height is important. Similarly, when we talk about relative velocity, it also possesses similar concept. Let us have one more example for the same. I think you must have experienced train journey, and when we look out the window, we can see there are some trains, right? If the train is moving in the same direction, if both the trains are moving in the same direction, and the first train is having, say for example, 100 kilometer hour, and another train which is passes to our train, say for example, it is having 120 kilometer per hour. So now see here, we feel, of course, the train number B, let's call B number train. We feel, yes, of course, it is crossing the first train, but we never feel like that it is crossing a 120 kilometer per hour speed. We feel somewhat lesser. And that is a relative velocity concept. Let's have another example. Suppose we are moving through a train. Right, this train, it is moving inside, and outside, if we see outside of the train, a person is somewhere on the platform, and that person is stationary. Our train is moving 100 kilometer per hour, and when we see outside, what we observe, the person is moving on a back side, but actually that person is a stationary one. So that is the thing, that is the relative velocity come into picture. That is the case where a relative velocity come into picture. We all like to overtake when we drive a car, and then in case of overtaking, such condition is happen when we have a higher relative velocity compared to other vehicle. And the picture you can see here, it's a Indian train, and we have observed this kind of situation, right? One train is moving opposite to the other train. Say for example, our train is running in the x direction 100 kilometer per hour and opposite train is running 120 kilometer per hour. What we feel? We feel like that opposite train is running too fast, is more than 200 kilometer per hour. And that's a relative velocity. That's a relative velocity. Let us understand with some deeper concept in the physical terms. So relative velocity is defined as velocity of an object with respect to other object, or simply we can say with respect to other observer. With respect to other observer. That means it is a relative velocity. We are comparing velocity with respect to some other observer. Let us understand with some more detail. Here, let us consider there are two cars. There is a red car and another is a blue car. Right? Red car is moving with velocity v1 towards, it is going towards left, and this v1 it is velocity with respect to ground. With respect to ground. Right. See, whenever we talk about any kind of velocity, majorly we compare velocity with respect to ground. Right. And here another car, it is passing with velocity v2 with velocity v2. Again, velocity v2 is also with respect to ground. With respect to ground. Suppose if this car V2, right, is going to overtake this red car is having velocity V1, that means V2 must be greater than V1. That means speed of this car, speed of blue car must be greater than speed of red car, speed of red car. So if a person is somewhere here inside the driving and another person it is in the car number V2. Right? Now this person wants to overtake V1 car. Let us assume this car V1 is having 60 kilometer per hour speed and V2 is having 80 kilometer per hour speed. So here V2 is having higher velocity compared to V1. Therefore, this car definitely it is moving at some higher rate, and of course it can overtake. It can overtake. But if we compare its overtaking compared to a stationary. Say for example, there is a person, it is standing on something, is having a zero velocity. If I compare this blue car's velocity with this person who is having zero velocity, so it is always of course 80 kilometer per hour. But a person who is inside this car and who is overtaking this red car observes 80 minus 60 kilometer per hour. That means 20 kilometer per hour. That is the relative velocity. That is the here relative velocity. When we observe our speed in this manner, that is a relative velocity. Suppose in another condition, a red car is coming on the similar track on the same line with 40 meter per second, and another yellow car is coming in this direction 50 meter per second is mentioned, and somewhere here and somewhere here, if both car stuck, is having a crash at somewhere here, if we see some crash. So what is relative velocity? This car is having 40 meter per second and the opposite car is having 50 meter per second. So what is relative velocity at here? See, at here it is having effect of 50 plus 40. Therefore, a relative velocity in between this crash, it becomes 90 meter per second. That means if we drive a car singly, this car drives, say for example, is equal to 90 kilometer per hour, and there is some pole, and if that accident take place on a stationary pole, and therefore a relative velocity, it become 90. So both effect are having equal, both are having equal effect. So now let us understand in terms of vector. Say for example, this velocity A is having in the direction of x is having higher speed. So bigger vector, say for example, this is equal to 100 kilometer per hour, and another vehicle is also moving in the same direction with 60 kilometer per hour, right? 60 kilometer per hour. In this vehicle number A, if we are seated in this vehicle, and this vehicle is moving at 100 kilometer per hour, what we observe, this vehicle number A, definitely it is approaching, it is moving in the forward direction, right, compared to this vehicle number B, because it is having higher speed. But see, relative distance travel, whatever this car, maybe after 1 or 2 seconds or 1 or 2 minutes, say for example, if this VA car reaches to this position, so VB car reaches maybe approximate up to this position. So this gap we see, that is a relative velocity. That means if we comparing relative velocity with respect to from A with respect to B, this VAB presents velocity of car A, velocity of car A with respect to car B, and is equal to VA minus VB. That means if you put here value, so it is 100 minus 60 is equal to 40 kilometer per hour. Right. So during this overtaking, the car which runs at 100 kilometer per hour, observe that the car is having 40 kilometer per hour relative velocity compared to another car. That is the relative velocity. If VA car is moving in the forward direction, is having higher velocity, that means a relative velocity with respect to B, right, with respect to B is always a positive number. And therefore its a relative velocity is always going towards this positive direction. Similar here, that car which is B is having lesser velocity and VA is having higher velocity. That means VA definitely overtake VB, and at that time this VB car feels that compared to A, they are having, this car is having lesser velocity, right? So therefore VBA, that means velocity of B compared to A, is equal to VB minus VA. Velocity of B is equal to VBA is equal to VB minus VA. Right. So see here, if you see VA, so first term is VA minus VB, second term is VB. Similar here, if it is opposite VBA, first term is VB and second term is VA. Right. So here sequence is very important, order is very important. A coming in first, and B is second. Here B is first, A is second. Order is very important. In the second case, if A is moving in this direction, X direction, and this B car is going towards opposite direction, negative X, right? So in this case, if this car is running at 100 kilometer per hour, and opposite car which is running 60 kilometer per hour. Right. So if a person is standing, is person inside this car observes relative speed with respect to B. If you see that car which is moving, so we see here always 100 plus 60 kilometer. That means 160 kilometer. 160. If there is a collision happens between these two cars, if both having accident, VA is running in this direction and VB is running in this direction and both observe accident. The effect of velocity become VA plus VB. VA plus VB. Right. So relative velocity, when we talk about relative velocity with respect to A, so it is always VA minus VB, but see here its side is opposite, that means VB is negative. So negative become positive and become VA plus VB. So when cars are running in opposite direction, you can use this equation VA minus VB. So in this case, you need to take VB as a negative term. Right. So this is the option possible. Again, what we need to understand here, a relative velocity of object A. Relative velocity of object A with respect to B is written as VAB, and VAB is equal to velocity of A minus velocity of B. Similar, velocity of B with respect to velocity of A is denoted by VBA, and is equal to VBA is equal to VB minus VA, and VAB is equal to minus VBA. Right, both observe the similar velocity, but both are having equal and opposite direction. Right, and here, see, this is, we talk about relative velocity. VAB is equal to VA minus VB. The similar concept is applicable for the acceleration. If we talk about relative acceleration A with respect to B, so that concept is also equally valid. The similar acceleration A minus acceleration B, and the distance travel SAB, relative distance travel, for that also distance travel by A minus distance travel by B, it is also valid. It is also valid. Right? No, a separate theory is required for that. We just need to understand relative velocity and the concept with relative acceleration as well as relative displacement. Both are also valid term. Right. So no separate study is required. You just need to understand only one concept, that is a relative velocity with A to B is equal to VA minus VB. This is the only requirement to understand. See, concept is very much important to understand. If you do not understand this meaning, real meaning of a relative velocity, then you may not be able to solve examples. Although you may remember equations and you may claim that I can solve the examples, but see, in the NEET and JEE and JEE advanced, the questions are somewhat tricky. Different concepts are merged together, and therefore there are possibilities that you may miss certain concept and answer may be wrong, and the wrong answer majorly it is available in the option, and that is big problem with this. So let us understand relative velocity with more detail, and how. By solving various example, if you are preparing for JEE and NEET and JEE advanced, always focus on examples. So first example is given. A plane is traveling is traveling at a velocity 100 km per hour. Let's do a plane. Wow. A plane excellent plan. A plane is traveling at a velocity, say for example, 100 kilometer per hour in southward direction. Say for example, this is a southward direction. Let us just assume southward direction. Now, it encounters wind traveling in the north direction. You know that north and south both are in the opposite direction. So wind is flowing in the opposite direction. Here, wind is flowing in the opposite direction, right? And the wind speed, it is given 25 kilometer per hour. We need to calculate a resultant velocity of plane, right? So plane is traveling at velocity 100 kilometer per hour as per its engine capacity, and suddenly there is some wind is flowing from the opposite side, which is having 25 kilometer per hour. So if you wanted to have a plane's relative velocity with respect to a wind which is flowing in the opposite direction, so we know that, let's assume UA is equal to velocity of a plane, and UB is, this is A and wind is B. UB, it is velocity of wind. See, it is taken here negative. The reason is that if we take south direction, let's take positive, let's consider positive direction. So therefore, wind is flowing in the opposite direction, so its direction should be negative. So now we have velocity of first object and velocity of second object. Now we need a relative, or you can say resultant velocity of plane. That means velocity compared to wind. So we know that equation, the relative velocity of A with respect to B, that means plane with respect to wind. So UAB always is equal to U first letter, you just pick first letter minus second letter. What is UA? 100. And UB, it is opposite side it is minus 25, right? So always consider relative velocity is always UA minus UB. Always take this equation. Do not take UA plus UB for the opposite direction. Do not take this equation, right? You just take one equation, otherwise you may have a chance to get error. So what is UA? 100, UB minus 25. Let's put here values. 100 minus become plus, minus 25 become plus. So it become 125. Relative velocity of this plane, it become 125 km per hour. Very simple. It's so very simple. Let's have another example. Example number 2. Appu is moving due east with velocity 1 meter per second, and Chappu is a character, is moving due west. See, both are opposite direction. Let's assume this Appu is moving in this direction. It is east, and let's make Appu. This is Appu. Appu is moving, speed is 1 meter per second, and the Chappu is moving in the opposite direction, right, west, and with a velocity 2 meter per second, and Chappu's velocity was 1 meter per second. See here, if we take direction east is equal to positive, therefore for Appu, of course it is positive, but for Chappu it becomes negative. So what is VA? VA is equal to 1 meter per second positive, and VB, or you can say UB, for Chappu it become minus 2. Our relative velocity equation with respect to Appu, That means A to Chappu, right? So our velocity equation V, or you can say U, whatever you want. A, Appu is for A, we are using A. For Chappu, we are using B. So it is AB. See, always you don't directly do not write AB like that. If it is asked like velocity with respect to Chappu to Appu, then the answer will be opposite. Answer will be opposite, right? So here, so it should be VA minus VB. It should be VA minus VB. It should be VA minus VB. So we know that. Put this value 1 and minus minus become plus is equal to 3 meter per second. Suppose if velocity was asked with respect to Chappu to Appu, if it is asked with respect to Chappu to Appu, so what equation? Equation become UBA is equal to UB minus UA. So UB is equal to minus 2, UA is equal to minus 1, that is always minus 3 meter per second, right? We know that UAB is always equal to minus UBA, right? If you do not go for this calculation, or you may directly write this also. That is also the correct one. So I think yeah, it's a very good going. Let's have one more. Example number 3. Three bodies A, B and C are moving in a straight line. Let's draw three bodies. Say for example, this is body number A, this is body number B, and this is body number C. We are talking about bodies, not dead bodies. Don't worry. So three bodies A, B and C are moving in a straight line in the same direction. All are going in the similar direction. Say for example, this is direction X, such that relative velocity is given. Relative velocity of A with respect to B. What is meaning of this? So that means V A B, first letter A, second letter B is equal to 2 meter per second. And can we write VA is equal to VA minus VP? Of course we can. Yes or no? We can. And second is relative velocity B of B with respect to C. That means relative velocity VB with respect to C. So B letter should come first, C should come later, right? This shows reference, relation, and this is, we are talking about velocity. Is equal to 5 meter per second. Can I say is equal to VB minus VC? Can we say this? Yes, of course. What we need to find velocity with respect to CA. C letter is coming first, A is coming second. Fine. Let us just resolve graphically. First, what is mentioned here? A rate of velocity of B with respect to C is 5 meter per second. Say for example, C is moving maybe 1 meter per second, 1 meter per second. So B should move 5 meter per second. Yes or no? B should move 5 meter per second. And it is mentioned that B, if it is moving 1 meter per second, B is moving 1 meter per second. So A should move double, 2 meter per second. If it is moving 1, then it should move 2 meter per second. But B is moving 5 meter per second. You just imagine the velocity of A. So let's solve. Let's erase this all again. So here it is given. First is VAB is given. You can use small a or capital A. Both are equal. There is an issue. So VAB is equal to VA minus VB is equal to 2 meter per second. Second is VBC. VBC is equal to VB minus VC, 5 meter per second, and we need to have VCA. Can we add VCA minus VA, and that is we required? Of course we can write. Can I do this VC minus VB plus VB, so I can cancel, right? So Yes, of course we can write. So here if I just make it bracket, so it become VC minus VB and that become VB minus VA. But here we have what we have? We have here VA minus VB. So VA minus VB. Can we write? Can we write in this form? And here we have VB minus V. So we have opposite. We have opposite side. We have both the opposite. So we can reshuffle this and we can write in this portion VB minus VA, VB minus VA, and for this case VB minus VC, VB minus VC. So what is VA minus VB? VA minus VA, can we write is equal to VAB? Yes. And VB minus VC is equal to VB minus VC is equal to VBC. Put this, both of them. So it become minus AB minus BC. Minus AB minus BC. Put this value here. Minus 2 minus 5. So C2A, 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 C2A. We have seen this part already. Let us see graphical once again. Say for example, this is C and a part which is moving B. So velocity of B, if it is first letter is coming, answer is positive. So it is moving somewhat 5 meter per second, 5 meter per second. So this is B compared to C, which is having relative velocity 5 meter per second, and A with compared to B, A is having relative velocity 2 meter per second. So it is ahead of 2 meter per second. That is 2 meter. That is 5 meter, and relation between C to A, that becomes 7. 5 plus 2, 5 plus 2, 7. But see, here, if you are talking about velocity of C with respect to A, so C is moving ahead and, sorry, A is moving ahead and C is lower. That's why this become minus 7. That's why this become minus 7. Because relative velocity of C with respect to A, it is in the negative direction. You can cross check your answer by using this kind of graphical tool. Otherwise, you just go for equation, that is sufficient for you. So let's have one more example. See, in the examination, definitely you are going to have somewhat tricky question, not so easy questions. And for that, you have to be ready for that. Let's read this, a big, lengthy question. Two parallel rail tracks run north to south. Let's do train. Let's have do train. This is our train, chuk gadi. This is train having some engine or whatever is having. Oh wow! It also I got some wheel. Fine. So train is moving maybe north south. Train A. Let us assume this is train number A moves north. Let us just assume this direction is north direction. Let us assume this direction is north with speed. So we can say VA is equal to 54 kilometer per hour. Right. And the train B moves south. See, train B, there is another train. Let's do another train. There is another train. Let's have different train. This is train number B. Moves in the opposite direction. Move in the opposite direction. South direction. With a speed. So VB is given 90 kilometer per hour. That condition is given, right? This condition is given. So we need to find first A. What is velocity of B with respect to velocity of A? So what is asked? First, velocity of B with respect to A. VBA we need to find. We have equation VB minus VA. VB minus VA, or you may use small letter also if you want. We can use VB VA. First letter it is coming first, second letter should be second. Right. So let's solve this. Here So for the first two cases, we know that velocity for the first train is given 54, and we are assuming, let us assume north side is a positive side. So first train runs at 54 km per hour, and second train, this is B, it runs in the opposite direction, therefore it should be negative direction. So speed of B is minus 90, and this um, we will see this afterwards somewhere, just wait for a few minutes. So here what happened, we need a relative initial velocity B. So first letter is B with respect to A, is UBA is equal to UB minus UA. So B first letter should come first and A should come next. Remember, this you have to remember. So here, put this value, UB is given minus 19 and UA is given minus 54. So here, relative velocity, not here BA, it should be BA. It is BA is equal to minus 144 kilometer per hour. Relative velocity with respect to B, train B with respect to A is 144 kilometer per hour. So first answer we got first. Now next is B. What is asked? Velocity of ground with respect to B. Here second is asked velocity of ground. Velocity of ground with respect to B. Velocity of ground with respect to B. See, we know that a speed which is mentioned of any of the train or any journey, it is always with ground. It is always with the ground. So velocity of ground with respect to B, we use V GB. G it is for ground, B is for B number train. V is equal to UG minus VB. What is UG? Ground has no velocity, therefore ground velocity is 0, and VB it is 90. So here again it should be G, GB, it should be GB, and therefore A is not A, it is V. VGB is equal to 90 km per hour. VGB is equal to 90 km per hour. That is our answer. Now next is C. Next is C, a velocity. Let's erase all the trains. Velocity of a monkey running on a roof of train A. So here the train number A, and on which there was some monkey, it is here playing maybe. Train A is moving in the direction and with the speed 54 km per hour. Right. A velocity of monkey running on the roof of the train A against its motion with velocity 18 km per hour. That means monkey's velocity is in the opposite direction, that is here 18 km per hour with respect to train A, right? So as observed by the man standing on the ground. So a person who is standing here, he is observing this. So we need to find velocity of monkey running on the roof with respect to person who is outside. So let's have, first let us just find velocity of monkey who is running on the train, right, and which is observed by outside a person. So here it is having 54. A is running at 54 and B is, or you can say monkey is running at 18, and person who is observing from the outside. So here A monkey is moving in the forward direction is equal to 54 minus 18. 54 minus 18. Right? Because velocity of monkey is in opposite direction. Therefore, a relative velocity of monkey compared to ground, it becomes 34 kilometer per hour. We can see also, right? If this if that monkey is suppose stationary, so that monkey moves with 54 kilometer compared to ground in the forward direction, but that monkey is running 18 kilometer in the opposite side. Therefore, with the ground, when I see with the ground, so it should be 54 minus 18. So therefore, then become monkey's velocity become 34. So this last question is tricky. Last C part is very tricky, that we need to understand. Here relative velocity we need to, when we talk about relative velocity, so here a relative velocity, it is not with train and monkey, it is relative velocity with the ground and train, that we need to understand clearly. Let's have one more question. It is here, example number 5. I think you should pause the video and now you should solve this example. If you solve unsolved examples, then only we can boost confidence. So here example number 5, it is mentioned, the driver of train A moving at a speed 30 meter per second sides another train B moving on the same track at a speed 10 meter per second in the same direction. See, both the trains are moving in the similar direction. So here let us assume this become VA and another speed that become VB. Now he immediately applies brakes and achieves a uniform retardation. Here it is talking about uniform retardation. So for example, it's A is equal to minus 2 meter per second square to avoid collision. Right? So this train is moving in the forward direction. Other train is also moving, but the speed it is 10 and here it is 30. Right? And we know that if brake is not applied, V1 is higher compared to V2. So definitely there can be crash. Collision is possible. So to avoid this collision, what happened? Driver applied brake, and because of that, there is a retardation happens of the V1, and that retardation is equal to 2 meter per second. So what must be the minimum distance between train A and B? What must be this minimum distance, right, at a time of brake is applied? What is the minimum distance at a time of brake is applied so collision can be avoided? Wow, it is an excellent question. This kind of questions you can see in NEET and JEE. So first it is given, first speed of first train UA is given and UB that is also given. This is UB and this is UA, both are given. Fine. Then see here, this question you may solve by using equation of velocities also, by using a relative velocities also. We have three equations from the chapter velocity, then which we have V is equal to U plus AT, this kind of equation we have. From that also we can solve. But this one is relative velocity is somewhat easier. So what is mentioned here? A relative initial velocity with respect A with respect to B, we know that is equal to UAB and is equal to UA minus UB. So at initial condition, what is the difference between these two velocities? UA is given 30, UB is given 10. That means train A is approaching 20 kilometer per hour. Right? That means there is a gap reducing by 20 kilometer per hour. We can say simply in the simple language. So we got VU AB initial velocity difference. or you can say relative velocity with respect to B of A. First letter it shows we are finding velocity for A, and second letter shows its reference. That you need to remember, and you need to repeat this. If you repeat, then and only you will understand. Now, see, if it is applicable for the velocity, relative velocity, so it is also equally applicable to acceleration, or you can say retardation, or for the distance also it is equally applicable. So you can say relative distance, you can call relative acceleration. So we can find relative acceleration AAB is equal to A of A minus A of B. A of A minus A of B. So see, initially at the time, right, when he saw that there is some collision, so he reduced its speed, so that become 2 acceleration of car A. But what about car B? That car was running at uniform velocity, that means acceleration was 0. So first for the train A, acceleration, this is given acceleration, right? Acceleration of A is given -2, or you can say retardation, that's what sign is minus. And B was having acceleration 0 because it is having uniform velocity, therefore a relative acceleration become -2. Relative acceleration become -2. Right. Now to avoid collision, right, relative final velocity of A with respect to B, it must be 0. It must be 0. That means this should become 0. If there is no collision, that means if V2 reaches to 10 km per hour and V2 is also having 10 km per hour and having some gap, maybe say for example 0 gap, that is also okay. Right. So velocity of both must be equal, or simply relation or relative velocity VAB must be 0. That means this value should be 0. This value should be 0. So we know that equation v square minus u square is equal to 2s. This equation is also applicable when we talk about relative velocity. But here everything should have relative. That means velocity should have relative AB, u should have relative AB, and A should have relative AB, as well as S should have relative AB. Everything should have a relative distance. So initially when we talk about V relation, relative velocity, final velocity should be 0. Final relative, that means VAB, that is showing VAB, that is also UAB, that is AB and SAB. Fine. So initial velocity, that was 20. The relation between these two, it was 20. So U square become 20. Final, there should be no relative velocity, so that is a 0, and a relative acceleration become -2. So -2 and put SAB. Find out SAB. So SAB is equal to 100 meter. So minimum gap between these two, that should be 100 meter, right, before you apply brake. So there will be no collision, right? See, this equation of motions, as I mentioned here, 3 equation of motion we already have, that can be utilized in case of relative velocity also. But condition is that all the items should have relative velocity. Say for example, V should be VAB, U should be AB, A should be AB, and S also should be AB. It is applicable to all. Similar example you can use by using these equations. We already have another equation, V is equal to U plus AT, S is equal to one more equation. What was the equation? Tell me. What was the equation? So by using that 3 equation also you can solve the similar example. But relative velocity, it is somewhat easier compared to that equation. So both the equation can be used and you can solve this. So what you do, solve this equation by using three equations from velocity or from the motion, and text me a comment me your answer. Let's have another question. Is it coming? Yes. Example number 6. The driver of a train moving at a speed v1 sights another train. Similar case, you can see similar case. At a distance d ahead of him. Very similar case, a train, it is here A, and driver saw another train on the same track with some distance d, right, moving in the similar direction. So both are running at the similar direction, so both velocities are positive, right, with the same direction with a slower v2. Again, let's read. The driver of train moving at speed v1 sights another train at a distance d. So velocity is given va, or rather say v1. So we can say here v1, and for vb it is given v2. Here it is given v2. It is smaller compared to v1. So this driver of train A press an immediate brake to avoid collision, right, and he achieved a retardation. So he is having a retardation, so it should be negative direction, and because of that, there should not be any collision between these two. And the four options are given. A is equal to v1 minus v2 square by a. Second is v1 square minus v2 square by a. C is given v1 minus v2 square by 2a, and D is given v1 square minus v2 square by 2a. So four options are given, right? Great. So what is given first? See, the two trains will not collide if the relative velocity with respect to A to B becomes 0. If there is no relative velocity, right, at a time of when they both meet, so they simply become v1 should be v2. So at that time there is no collision. We know that. So UAV, relative velocity between final velocity of first train and final velocity of second train, if both are reduces to 0, right? So then you can say relative distance, let us assume S is equal to D. We can put is equal to V square minus U square is equal to 2AS. Here again I am mentioning here, it is equation is actual equation, you can write like that. VAB square minus UAB square is equal to 2AAB S AB. So we know that final velocity should be 0. Final velocity should be 0. And what about U? So this is final velocity. So initial velocity, this is initial velocity. UAB is initial velocity is equal to V1 minus V2. Put this here. This is initial velocity V1 minus V2 square, and opposite A, acceleration is negative. Acceleration should be negative, multiplied by SAB. So SAB, that is distance, is equal to V1 minus V2 square divided by 2A. Which one is correct? This is not. V1 minus V2. Yes, C, answer number C is correct. So this kind of questions you may see in the examination. If you want to understand this question again thoroughly, I simply suggest that you again go to example number 5 and try to solve by yourself. You will understand this question very well. Only one thing is that if you want to avoid collision, then see, relative velocity. It is relative velocity should reduce to 0. Let's have one more question. So it was asked in All India Pre-Medical Test in 2009. What are you waiting for? You pause the video and solve this question, and otherwise you can never learn the topic. I hope you must have solved this now. So example number 7, a bus is moving with a speed. So bus speed is given. 10 meter per second on a straight road. Bus is, like for example, bus is moving in this side. This is our bus. Is moving in the straight road with 10 meter per second. A scooterist means a driver of a scooter. Let us have a driver of a scooter. Wow, what a scooter! Excellent. A scooterist wishes to overtake bus. Oh, scooterist wishes to overtake. Do not overtake bus. It is bad. Overtake a bus in 100 seconds. So with the time, 100 second, within 100 seconds, this scooterist wish to overtake. The scooterist is taking a risk here. So here, within 100 second, this scooterist wishes to overtake this bus. It is very interesting. So if the bus is at a distance 1 kilometer from the scooterist, let us again redraw this frame. Let us have once again. So this is a bus which is moving on a road. This is a bus. This is bus which is running 10 meter per second, and here there is a scooterist, right, having some velocity we don't know. That's a VB, and this is VA of a bus, and the distance between these two is 1 kilometer. Distance between bus and the scooter, it is 1 kilometer. Right. So what should be VB? What should be VB? What should be VB to overtake this bus in 100 second? In 100 second. Wow, excellent question. So velocity of scooter should be 20 meter per second, 40 meter per second, 25 meter per second, or 10 meter per second. 10 is not possible because if a scooter is run at 10 meter per second, it never cross this bus, because if both the velocities are equal, relative velocity becomes 0. Wow, interesting question. How to solve this? Give me an idea. So we identify all the given data. So first it is VB is given 10 meter per second. Let us assume this is B and this is A. Let us assume opposite one. So VB is given 10 meter per second, that is for bus. B is used for bus, fine, meter per second. T is 100 second. And the distance, relative distance, or simply you can say distance. This distance as relative distance, you can say distance between moving bus and moving scooter. It is 1 kilometer. You can convert this into 1000 meter. Right. And let's have velocity SB. That means velocity of scooterist. This is, let's do again. I love this example. This is bus running with velocity of B. Here it is a scooterist running with velocity of, let's call S, and he wants to overtake this bus. So here we need velocity of scooterist compared to velocity of bus, and that should be positive, then only he can move. So we know that VSB is equal to VS minus VB. VSB is equal to VS minus VB. We have value of VB, means bus velocity, but we don't have scooter's velocity. So we need to find this. We need to find this value. So VS we don't have. VB we have. See, if we wanted to have a scooter's velocity, at what relative velocity that person should move, so this person has to travel this 100 meter in the given time. It is 100 seconds. So relative velocity with respect to bus, it should be S by T is equal to 1000 divided by 100. So 10 meter per second. Put this relative velocity in this equation and you will get answer. You will have answer. You will have answer. VSB is 10. We need to find Vs, scooterist velocity and opposite V. What is velocity? Scooterist has to run his scooter at 20 meter per second. He has to run scooter at 20 meter per second. Very interesting question. Let's have one more. So let's have one more question, example number 8. Why don't you pause the video and solve this question by yourself? That's all. A train of 150 meter length. Here it is given, a train is given, a train. This is the train, let's assume this is a train. He is having length 150 meter. He is going towards north. Let us assume this direction is north. Let us assume this direction is north and it is a positive side. This is a positive side. At a speed 10 meter per second, that means velocity of train is equal to 10 meter per second. A parrot flies. Let's change the color and let's have parrot. It is having, wow, what a parrot. Excellent. So parrot flies in the opposite direction. Parrot flies in the opposite direction towards south, and therefore velocity of parrot, let's say Vp, it should be minus 5 meter per second. Right. Parallel to the railway track, the time taken by the parrot to cross the train. So that means parrot is crossing this 150 meter distance with its velocity Vp. This is wrong, not with Vp, but it is traveling with velocity Vtp. That means train's velocity with respect to parrot, or you can have opposite also is true. Parrot, you can say Vpt, parrot's velocity with respect to train, that is also okay. So here it is a case of relative velocity. It is a case of relative velocity. So here it is given, Vt is given 10 meter per second. Parrot velocity, as it is in opposite direction, so it is negative, minus 5 meter per second, and the distance has to travel by parrot is 150. So we know that velocity of parrot with respect to train or train with respect to parrot, we can write Vpt is equal to Vp minus Vt, and it become, parrot is not 10 but it is minus 5, and here it is minus in bracket 10. So final solution, final answer, it become minus 15 meter per second. Minus 15 means 15 or positive, negative, it doesn't matter here. Vpt is 15 meter per second. So relative velocity is, this is the equation. Then what next? Time taken by the parrot to cross the train, and that we know that velocity is equal to distance travel or relative distance travel. So total 150 is travel in time t. So t is equal to s divided by v sb, or you can say v is pt. We can put here pt, and let's put here all the values. S is distance 150 meter and velocity we got here minus 15. So time is 10 second. Time is 10 second. 10 second. Is it given? Yes, it is given. The question was asked in All India Pre-Medical Test 1992, and beware of this kind of questions. Example number 9. JEE 2019 mains exam, the question was asked. So why don't you pause the video and solve the question by yourself? See, if you solve unsolved examples and if you get the correct answer, it brings a joy, and as well as it also brings confidence. So let's have example number 9. A passenger train of length 60 meter travels, so passenger train is given, passenger train is given, say for example A number train, and the length is given 60 meter, travels at a speed, velocity of A is equal to 80 kilometer per hour, right? And another freight train of length 120 meter travels at a speed. So let us assume another train, there is a one more train, B travels, let's say VB is equal to 30 kilometer per hour, travels 30 kilometer per hour, right? So it is asked that the ratio of times taken, let us say time taken by this one and time taken by this is T2 something, by the passenger train to completely cross the freight train when the first condition, there are two conditions are given for the T1 and T2. So condition 1 is T1 and condition 2 is T2. Let us just assume 1. If they are moving in the same direction, if both the direction trains are moving in the similar direction, so VA is having 80 kilometer, VB is having 30 kilometer, therefore it is going to definitely cross. So we need a time by which train crosses. We need a time by which train crosses. Let's start. So now see they are moving in the similar direction. We need to find a relative velocity. And the data is given VA is 80. Distance for the first train, let's assume SA 60, and for the second train, it is given 120 meters. That is given time SB. And VB is equal to 30 kilometer per hour is given. So first we can find relative velocity of A train with respect to B. So we can get VAB is equal to VA minus VB. VA is given 80. Put the value here. VB is 30. Both are having the similar direction. Therefore, it is not negative. And relative velocity of AB that become 80 kilometer per hour. Let's redraw this train once again to have better understanding. So train A, right, this is train number A and this is say for example train number B. Right. Let's change color. So train A, it start right overtaking from this position, right? So train A can move, say for example this distance is SA and this distance is SB. This train overtakes, reaches, or you can say it travels distance and it reaches somewhere here SB. So both the engines are reaching here. Therefore, train travels SB. But the train A, we can say a complete travel if the train completely reach, or can say completely it goes outside of this P. And when it happened, when this SB plus SA distance taken place, and that time it, in this case only it is happen. If you take distance from one side, maybe distance from this end to this end travel, so it is equal to SA plus SB. This is total travel will happen in this case. So relative distance between two train, it 120 plus 60, that become 180 meter. For the complete overtake, this entire distance has to travel by train A, and therefore relative distance become 120 plus 60 is equal to 180. Now it is very simple. Now relative velocity is equal to distance travel in time T1. We can put T1 is equal to SAB VAB. So we got equation 1, equation for the time T1. So we got equation for time T1. Second equation, in the opposite direction, if the trains runs in the opposite direction. If the train runs in the opposite direction, right? If the train runs in the opposite direction. Now, one train is running in this direction, VA, and the another train is running in the opposite direction, VB. Therefore, relative velocity VA is equal to 80 and VB that become minus because the direction is opposite, therefore VB become minus. So relative velocity with respect to B, so VAB is equal to first letter should be VA, second should be VB, that we know very well. So what next? Put the value so we can get relative velocity is 110 km per hour. And what is distance has to travel? If we talk about again the distance travel, this train is moving in the direction SA and other distance it is SB. If there is a complete travel, that means this entire region has to be crossed. That means total distance again that become A, SA plus SB. Whatever direction it is given for a train, total distance travel has to be length of both the train. Otherwise, if you just subtract like that, your answer will be wrong. So radial distance travel from A to B, that is 120 plus 60, that is 180. So relative velocity AB is equal to relative distance AB divided by time T2. So we got T2, put the values for SAB and VAB. And now what next? So we got T1 is our first equation, T2 is our second equation, and put T1 by T2. Put T1 by T2. 180 should be cancelled. That should go upside. 0 cancel. 11 by 5. 11 by 5. It is available. The answer is available, right? Correct answer is available. Of course it is available. Let's say one more example. Example number 10. A passenger train 250 meter long. So this is distance is given for the train A. Moving with a velocity VA 72 kilometer per hour. Overtakes a goods train moving on a parallel path. So this train is moving 72 kilometer per hour. Overtake another train which is moving parallel with VB velocity, and what is mentioned here, it completely in 45 seconds, right? Overtake happens within a 45 seconds. If the length of goods train is given 200, this is goods train is given 200, not V but S goods train SB is given 200 meter. Determine the speed of the goods train. Equation, this example is very similar to example number 9. Here first we need to find a relative velocity. First we just need to have relative velocity. So let us have given data. Trains are moving in the same direction. Both are moving this direction. And the given data, we can take given data. So velocity of first train VA is given 72 km per hour. This distance of train A is given 250 meter. Then VB, what is the speed of train B? That is not given, we need to find. But SB is given, and the time taken for the complete overtake. The trains overtake both the train, this another train. So this train, we can say relative time is equal to 45 seconds to complete overtake that is required. So first we just need to have relative velocity of train A. This is given, right? And we need to also convert this kilometer into meter per second because our answer is required in meter and distance is also given in the meter. So we know that 1 kilometer is equal to 1000 meters. So multiply by 1000 hour. You can convert this into seconds. So 60 multiplied by 60, that gives 3600. That equal to 20 meter per second. You can just divide by 2. Now what next? What next? You can convert a relative velocity with respect to B is required. VAB is equal to VA minus VB. Both are running in the same direction. Therefore, VA and VB both are positive. So, VA is 20 meter per second and VAB we don't know. VB we need to find. We need to identify VB. Now what next? What next? Now what next? Now see, during this overcome, train starts from this engine, right? So this entire length train has to cross. Then only train can overtake. That means the engine starts from this position, and then it reaches to another position, so it travels 200 meter. But that the last, you can say, guard, it is already there. It is somewhere here. So that also travel fully, and then become always 250 plus 200. That always become 250 plus 200 total distance. So total distance train has to travel in the relative. If direction, if whatever both are having equal or both are having opposite direction, in both the cases, total distance traveled by train, it is always summation of two distances. So as AB become 450 meter. Now it is very simple. We need velocity, relative velocity. AB is equal to SAB divided by TAB. Put VAB here. SAB, it is already here. TAB is already given. 45 seconds. Put the values here. Put the values here. Put the values here. Put the values here. So we can have divide this, become 10, and VB is equal to 20 minus 10. So it become 10 meter per second. So this train is running 10 meter per second speed. So this kind of questions you will see in the NEET or JEE examination. Be ready for that. We need to convert this into kilometer per hour. If answer is in kilometer per hour, so we need to convert. So multiply by 360. Exactly opposite you need to do. Exactly opposite need to do. So become 36 kilometer per hour. 36 kilometer per hour. Depending on the option, if answer is asked in kilometer per hour, so you need to convert. If it is asked in meter per second, no conversion is required after that. But during calculation, it is you have to identify unit should be similar. Unit should be similar, right? Let us solve example number 11. Before I solve, I think you should pause the video and you should solve this by yourself. So what is given? A passenger train is 240 meter long. Say for example, this is passenger train. Call name A, and the length of this train, say for example as A, we can mention here 240 meter, and is moving with a constant velocity. Say for example, velocity of train is given VA is equal to 72 kilometer per hour. At a particular time, its engine, say for example, this is engine of train 1, or you can say train A. Engine approaches last compartment of goods. Let's change the color. Last compartment of goods. So this is the B train, and this is the last compartment of goods. Last compartment of goods train moving on the parallel track in the same direction. So both are moving in the same direction. Both are moving on the same direction. Fine. So what happened? 25 seconds later, engine starts overtaking engine of the goods train. Wow, excellent. So after 25 seconds, engine reaches somewhere here, which is nearby engine of goods train. So in the 25 seconds, the train travels from end of the goods train to the engine of the goods train. That means it travels just length of train B. Let's say SB is equal to length of train B, and SA, it is the length of train A. So see, within 25 seconds it is traveling SB. So up to this it is interesting. Then it took 30 seconds more. That means it is now train is again continuously. It is taking 30 more second to complete overtake. See, train already traveled SB. Now train has to travel the remaining distance. Remaining distance is SA. We know that always total travel is equal to SA plus SB. Right, from end to engine of train B, train is initially travel in the 25 seconds, and from right remaining SA distance it is taking 30-second time, right? So for that it is very tricky question. So let's start. So what is here? Trains are moving in the same direction, and velocity of first train is given 72. Both are in the direction, similar direction. Distance, for example, length of the train A 240 meter. Velocity of B, train B, we need to find, and also we need to find length of the train, length and velocity or the speed we need to find, and the time is given. Two times are given, right? One is not 45, but one is given 30 and 25. Two different times are given. So let's case first. Let's solve. Train number A, VA is equal to 72. So we just need to convert this into meter per second. 1 kilometer is equal to 1000 meters. So put here 1000, and 1 hour is equal to 60 multiplied by 60. So it is minute and it is second. So become 3600 second. So divide by this. So it is very simple. But see, you have to revise this all every time. Then and only you can remember. Otherwise, at the time of examination, you may forget this one. So now relative velocity, we wanted to have relative velocity of train A with respect to B. We know that VAB is equal to VA minus VB. VA is given 72. VB is we don't know. So let's just put here VA 72. It is converted 20 meter per second. So VAB is equal to 20 minus VB. That is very simple. And see, VAB is constant. Relative velocity is constant. The case is for the constant. Now see, a relative distance traveled by train A from the last compartment to the engine. That means that distance is SB, and it is taken 25 seconds. So we know that SAB is equal to SB meter. During the first travel, this travel, that traveling is SB. So we can put velocity is equal to distance divided by time, and the distance we have. We don't have distance, we have velocity. So put this here, time we have 25 seconds, and just put this as equation number 1. Just put this as a equation number 1. Let's erase everything. So we got equation for this condition. It is in the 25 second engine reaches from end of the train to the engine of the train, and that is taking 25 seconds, and the distance travel, that is SB. Fine. Now for the remaining case, it took 30 seconds more to complete overtake train. So that means to travel remaining distance, remaining distance is 240 meter. If this entire train is traveling, so this distance travel, it is taking 30 seconds. 30 seconds is very easy. So you know that relative distance, it is taking just 30 seconds. So 240 is relative distance. VAB is equal to this distance travel 240 divided by its time. It is taking 30 seconds. VAB we have VAB. Put the VAB here. Put the VAB here. Put the VAB here. And 8. So it become 8. And VAB, not VAB, VB. Speed of the train 2, it is 12 meter per second, and you can put this value in the equation number 1, so we can get distance travel is 200 meter. That means, see, this train distance SB is equal to 200 meter. Very simple. You can convert velocity in kilometer per hour. So it is 36 kilometer per hour, and SB you can convert into if you want. If it is asked, so you can convert this point to kilometer, but it is in meter. Fine. Right. So question number 11. It was somewhat tricky. I think you again solve this example without seeing this video, and then after you compare. Otherwise, you may lose this example. Let's have example number 12. So you pause the video and you should solve this now. Do it. So I will mention two trains A and B. So trains are A and B are moving on parallel tracks, in the opposite direction. Oh, so A train is moving in this direction and then another train B is moving in the opposite direction. Velocity of VA is twice of VB. That means VB. Wow. They take 18 seconds, so they are taking 18-second time. Right, so T is taking 18-second, T, AB or B or whatever 18-second time to pass each other. So total distance, whatever train is having, total distance travel, it is taken 18-second, and determine their velocities. If train A is having 200, so SA is 240 meter and SB is having 300 meter. Wow, excellent question. So given data, trains are moving in the opposite direction, therefore this VB should be negative. Given VA is equal to 2 VB, that is given, fine. TAB, that means relative distance travel in 18 seconds, and SA is 240, SB is 300 meter. Fine. So relative velocity, if you wanted to have, so VAB is equal to VA minus VB, and VA is equal to 2VB. VA is equal to 2VB. But this train runs in the negative direction, therefore VB, that should be in the negative terms. So here VA is equal to 2VB and VB is equal to VA divided by 2. VA divided by 2. But this direction is negative, therefore that sign should be minus. That sign should be negative. That you have to remember. So VA minus, put the values here. Minus minus become plus, and let's erase this all. VAB is equal to 3 by 2 VA. VAB is equal to 3 by 2 VA. Now what next? Total distance travel. Total distance travel we already seen by both the train is always is equal to SA plus SB. It does not depend on direction. It is not dependent on direction. If both directions are similar, in this case also it is always SA plus SB. If it is opposite direction, again it is SA plus SB. So real distance 240 plus 300, 540 meter, and relative velocity is equal to relative distance divided by TAB. Put the values here, VAB we have, or from the top you can bring here, SAB we have, right? Put everything here, time we have 18 seconds it is taking, and VA is 20 meter per second. So VA is taking 20 meter per second. If it is asked in kilometer per hour, so you just convert this into kilometer per hour by multiplying 3600 divided by 1000. If it is asked. So answer is 72 kilometer per hour. Answer is 72 kilometer per hour. Oh, this is it. Thank you very much for watching. This is